Okay, so we use this system of three equations and three unknowns. Now uh, I asked to figure out which two equations I'd like to use to eliminate a variable. And the majority choice was to pick on the 2x and the 4x, fairly natural choice. So we rewrite those two equations. Now, we're not always going to rewrite the two equations while I'm doing it, but I want to separate things out so that we see what's really going on. Then we'll kind of do it in a very coherent process. Okay, so we have the 2x and the 4x here, and we want to eliminate x. Well, it should be clear that we can multiply the first equation by -4, by -2, and that'll give us a -4x, which will match up with our 4x down here. Now, we need to write out the rest of the equation. So -2 times 2y is -6y. -2 times 4z is plus 8z. And -2 times 9 is -18. Then, second equation is just going to be as it is, if we can manage to copy that down. Oh, it's got a 2 there. I knew I didn't have 1 or 2. Anyhow, okay, so there's the two equations. So when we add them, we get the equation -y plus 6c equals 11. Okay. So that's pretty easy. Now I've got an equation in y and c. Can we eliminate x from a different pair of equations? Well, we can. We could eliminate it from these two or from these two, right? We want to eliminate x because we want to get another equation in y and z. If we get another equation in y and z, then we have two equations and two unknowns, and we know what to do with that. Okay, so let's just pick the lowest numbers, the first and the second, right? So we'll come over here and do the whole thing again. We got 2x, 3y minus 4z equals 9. The second equation is 3x minus 12y plus 12z equals -21. Okay. So in this case, we're probably going to have to multiply both equations by different numbers, each equation by a different number. So can you do that? Okay. So here we go. So we choose these two equations, or the class chose these two equations to eliminate x. Could have chosen this one and this one. It wouldn't have made any difference. And everybody, I think, saw pretty quickly that I think most chose to multiply equation 1 by 3, which gives you 6x plus 9y minus 12z equals 27. And then -2 times equation 1, which gives you -6x plus 24y minus 24z equals 42. If you want to check my arithmetic there against yours, you got the same thing. Everybody got the same thing. There's a good chance we're right. Okay. If you add these, then the 6x's go away. 9y, 24y is 33y. We have -36z. And then we have -15. And this is not coming out as nicely as I intended. That's okay, they usually don't, so we might as well just deal with it, okay? So what we have here now, and here gives us a system of equations and two unknowns, okay? Okay, so now this will be our equation one for reference. This will be our equation two. And we have two choices. We could multiply the first equation by 33 and match up the y's and eliminate y. But we're probably going to just multiply the first equation by 6 and eliminate z because we'll be dealing with smaller numbers. Okay, so we're going to do 6 times equation 1 and equation. It's going to give us negative 6y plus 36z equals 66, and 33y, 33, minus 36z equals negative 15. And that gives us 27y equals 51. Now this is a bit of a pain. I was hoping these would come out with a whole number solutions, but I did something wrong in my head for the first time in doing these equations, not for the last time, certainly. That's okay. We're going to deal with it. Okay. So we solve this and we get y equals 51 over 27. Okay. Now we can plug that in either of these equations to get the value of z. And I'm just going through this because I'm assuming everybody knows how to solve two equations. Give us the equation minus 51 over 27 plus 6z equals 11. We multiply both sides by 27, which is going to give us pretty big numbers. That's 162, I think. And that would be 297 if I do my multiplication right. So here's equation one. We do 27 times the equation. And we get this, and it's 162z. You get 162z equals 347. I'm doing these numbers kind of quickly. They're probably not quite going to work out. So z equals 347 over 162. And I'm pessimistic about that reducing. Okay, 2 doesn't work. This isn't divisible by 3. Neither one's divisible by 5. This isn't divisible by 7, and neither is this. You try 11, but that's not going to be divisible by 11. And beyond that, actually, you can just accept that as the lowest common. It's the reduced fraction, although there's an outside chance that, well, we wouldn't want to try anything more than 11. So what I've done is just in my head, I've eliminated the prime numbers 2, 3, 7, and 11. Okay, which is sufficient to tell me that these things don't have common factors. Okay. Um, this one's divisible by 2, and then it's divisible by 3, like 4 times. It's 2 times 3 times 3 times 3 times 3. Okay. That one doesn't reduce it the least. Okay. Matter of fact, I don't think any of those numbers divided this. There's a good chance that's a prime number. Okay, well, that's aside. Okay, so we now have values of y and z that we could take and plug back into any of our original equations. Okay. Now, since we've used equation 1 twice, I'm going to choose to plug these numbers into either the second or third equation, each of which has only been used once. So I'm going to take a big old arrow up here. I'll go to the second equation. And here. And I get the equation. 3 times 51 over 27 minus 12 times 347 over 162 plus 12z equals negative 21. Now 162 is a multiple of 27. 6 times 27 is 142. So we can multiply through by 162 here. All this equation 1 again, and we'll do 162 times the most recent equation 1. That's saying we solve for z and then check. Okay. Now, all of that is very straightforward. It's just there are a lot of steps and a lot of opportunities to make an error. And I've probably got an error in there somewhere. Okay. It doesn't just get these fractions getting out of hand and stretching the bounds of what I can do in my head accurately. I got all kinds of stuff in my head. A lot of it's not accurate. Okay. So what's the strategy? We pick 2 equations, we pick 2 other equations, right? And we eliminate the same variable from both equations so that now we've only got a system of 2 equations, and we know how to do that, so I went through this kind of fast. Once you have your solution for y, you plug it back into one of these equations and solve for z. Now that you got y and z, you can go back to any one of your original equations, preferably not the one you used twice. But that probably wouldn't make any difference. Then you get a solution, then you check it in one of the other equations. Okay? Okay, well, that's what we could do. Now let's do it a little more compactly. That's using check to make sure that I've got good numbers there. Yes. It should have been 11. Notice I had 7 in the original. So this system is a little different than that one. Okay. But this one should come out a nice solution. but it's gonna be a little bit of a pain. Well, I can write this as an augmented matrix, 2, 3, -4, 9, 3, -12, 12, -21, 4, 5, -2, 11. Okay. Now, my goal is to reduce this matrix to this form and see what numbers I get here, because this number is going to be X, this number is going to be Y, and this number is going to be Z. Well, I want a 1 in the first column. You know, I could get a 1 in the first row, first column, upper left, right? I could just divide the first equation by 2. Then I'd have a couple of fractions. I'd have 3 halves and I'd have 9 halves. You know, the order in which these equations is written makes no difference. So I got row 1, row 2, row 3. I'm going to put row 3 first, then row 1, 2. There's a reason for that. It's because I noticed that all 3 of these numbers can be divided by 3 with no fractional result. Okay. So I can always switch rows. Okay. So now I'll put the second and then last row, being kind of careful to copy them accurately. And then I'm going to take the first equation. I can divide the first equation by 3 and get 1, -4, 4, 7, which is kind of handy. These are the biggest numbers I've got, so it makes them smaller. But mainly gives me a 1 here. So then I still write down the second and third. Okay. Now I come up all the way up here. Well, I'm just going to come up to here. Okay. And I write down, well, I'm going to need the whole part of it. What I'm going to do next is I'm going to keep row 1 where it is. And I said this is 3 divided by, that's not row 3 divided by 3. Row 3 would be this one. Okay. It's row 1 up here divided by 3. So I got to be a little more careful. Okay. Should be clear. I don't have enough room to write out my rules. Fix that a little bit. And this over. Even I think you can see it, what it was. Okay. Okay, so I come up here and I write down double brackets. And I'm going to have row 1, which is just the same as it is here. I don't want to mess with row 1. Because I've got the 1. Okay. Now later on I'll mess with it a little bit. Okay. Well, I'm going to do row 2. Two times row 1. Okay. I do all that off to the side. Minus 2 times row 1. Row 2 is 2, 3, -4, 9. Row 1 multiplied by -2 is going to give me -2, 8, -8, and let's go down 14, -14, which adds up to 0, 11, -12, -15. Okay. Now, do you understand what I did here? I took row 2, which is, here's my last matrix, okay, before we get this one. At this point, we're looking back to this matrix, and row 2 is the 2, 3, -4, 9. Okay. And I do -2 times row 1, which will give me a -2 here, and eliminate that x. Because remember, my goal is to get zeros down below this 1. Okay. So I got the 1 by dividing the first row by 3. And now I'm going to get a 0 here because the operation row 2 minus 2 times row 1. That gives me 0, 11, -12, -15. Then I do row 3. What am I going to do to get a 0 here? Well, I'm going to multiply the first row by -4 and add to this. Okay. That's 3 minus 4 times row 1. Now I can write that out. I'm going to use some of the board skills I have down here just for scratching. Row 3 is 4, 5, -2, 11. -4 times row 1. Well, write that out for what's -4 times row 1.
Three times -11 too. Right, I haven't written it down, but you would multiply this one by 21. Or no,
5, row 2 here.
yeah,
Or you divided row 2 by 11, right? That's how you got this right.
the one, but to get a, we would have to do this again, right?
Now you're going to want to get a 0 here.
Yeah.
So
I would,
you're going to have to do something like this. Right?
yeah, I'd have to.
You could multiply by 21, but since you want the number to be actually do the negative. That's exactly right. If you multiply by 21, it'd be okay, but you'd have to subtract. And that's a little more confusing than that. If you keep your which value, it works just fine. Nothing incorrect about it. Very good. Okay, at this stage, the fractions get a little bit noxious. Negative 21 times 1, of course, is negative 21. And we add that to 21, we get 0, right? You write that out to the side if you wish. Then negative 21 times negative 12 over 11 is plus 252 over 11 if I do this right in my head. These numbers aren't that difficult to do in my head, but use a little caution. Negative 18 times 11 over 11 is negative 198 over 11. So we're going to have 252 over 11 and negative 198 over 11, which is 54 over 11. And over here, I'm going to erase this. Instead, I'm going to keep this off, but that's how I calculate it, okay? Actually, I'll leave it there for me. But, and understand that I'm just trying to add negative 21 times this row to this row. Well, negative 21 times negative 15 is 315. And then 17 negative 17 is negative 187 over 11. So it looks like I'm going to have a plus 315 over 11 when I multiply this by 21, and a negative 187 over 11 when I take this negative 17 and write it as a fraction. And that's going to give me 128, I think. Now this is getting way too involved with fractions, so I'm not going to take it all the way to the reduced echelon form, something we call it. You don't need to know that terminology. But now I'm going to write down 1, 2, 3. Got 1, negative 4, 4, 7, 0, 1, negative 12 over 11, 0. If I multiply this by 11 over 54, I'm going to get 1, right? That's going to give me 1. And then the last number here, and I am going to erase these fractions here, just to give myself room to avoid confusion. Okay, 11 times 128, that's 1280 plus 128, which is, you know, it's 596. And of course, that can be reduced because this is divisible by 4, and this is divisible by 4. Okay. So we can reduce this fraction quite a bit. But I'm just going to write it out in all its glory. So what do we know? At this stage, we know z equals this. Okay? Since we know that z equals this, what does this equation say? It says z minus 12, y minus 1211 z equals negative 15 over 21, right? So what we have is, yeah, actually got room to write it here. Z equals, okay. 1308 over 596. Divided by 4, we get 426. Then 149 is probably prime. So Z equals 426 over 149. That's from our last equation, right? If I reduce that correctly, and if I did all my fractions correctly, which is very questionable, then I have y minus 1211 z equals negative 15 over 11. In other words, this is my equation 3. This is what my row 3. Row 3 corresponds to this equation. Row 2 corresponds to this equation. And row 1 is x minus 4y plus 4z equals 7. Okay. Now, we call this upper triangular form. If we do a diagonal down through this 3 by 3 matrix on the left, okay, diagonal has all ones on it and zeros down below. So what we have left is the triangle here. And the triangle I've got here has all zeros above a diagonal, right? This triangle doesn't have zeros above the diagonal. But still, this is very useful, and often this is all we do. And it might be all open math even tells you to do, okay? So what we have is an equation z equals 426 over 129. Well, we can plug that number in for z. That's going to give us an equation we solve for y. Okay. Now we know y and z, so we can plug in z, still 426 over 149. Y, whatever in the world that comes out, it's going to be a mess. Okay. But we can plug it in, it's just a number. Z is going to be a number, y is going to be a number, and we can solve for x. Okay. I've almost certainly made an error somewhere, and I still can't find it, but I'm sure I made an error in these equations. Because the solution should have been 1, 1, and negative 1. And when I check that with what I've got here, every time I check, I get it right. 1 and 1 for x and y gives us 9. Minus 2z, well, z is negative 1. That means we add 2, we get 11. Okay. Here we get 3 minus 12, which is negative 9. And then we add 12 times negative 1, which is negative 12, we get negative 21. And here we get 1 and 1 and 4, and that adds up to 9. Either I copied something down wrong here, made a mistake early in the equation. But I can't seem to find it. I suspect that maybe this should have been 11 and 22, but I don't see how that's here. So all that aside, I'm not going to ask you to do anything that has fractions of that complexity. But what I want you to see is the process. Okay. It's taking off on the process that we use with 2 equations. We wanted to get the 1001, that little 4-unit matrix. Now we want ones on the diagonal and zeros below. If we get to that stage, we can do this. That's called back substitution. Figured out now what z is. We can substitute that back into the equation for y and z. Then we get y, and we substitute then the y and z back into the first equation, and we get a solution. Okay. And for anything I'm going to put in the example, double or triple simple. Actually, produce it from the program that starts with values of X, Y, and Z. And generates matrix, then get to do it after, okay? Does that picture make sense? Now you can compare that with what we did originally, where we started with our system. Pick two equations, eliminated X, picked another two equations, eliminated X, right? Which gave us two equations and two unknowns. It was solved. And then we back substituted here to get Y, or to get Z. And we back substituted Y and Z up here to get the equation that'll give us X. Wait a minute. I wrote this down, I wrote it wrong. Y equals, okay. Y was 51 over 27. So the minus 12, Y was minus 12 times 51 over 27. And Z was 347 over 162. And X was still unknown. I was very careless before I plugged in my numbers, okay? So, and I did that intentionally because I want you to be aware of the pitfalls. No, I didn't do that intentionally. But keep yourself focused. But anyhow, we still then multiply this equation by 162 and solve for Z. I don't recommend you actually do that. It's more work than I really want to make you do. All right. Well, there's nothing I can tell you, but I think if you hit your saturation level for the day. That's the ultimate process. If you do that, and one other simple thing, then you got the system's equations and the matrices pretty well knocked. And I think you're in good shape to get there. Little practice, so you're sure you're going to be able to do it when you get in the final.